Let's remind you the example from our lecture 5 segment 3. We had a question there. The last question was, suppose you are rolling 3 dice and you are expecting all 3 of the results to be greater than 3. What is the probability of rolling numbers greater than 3 from each of the die? That was a question, and the result was 27 over 216, where E3 was the event of rolling number greater than 3 from each of the die. So now this 27 by 216 could be reduced to 1 by 8, but we didn't do so because there's a reason. So anyway, this fraction actually came from 3 times 3 times 3 divided by 6 times 6 times 6. Now it could be rearranged like 3 by 6 times 3 by 6 times 3 by 6. Okay, so my question to you is whether this fraction looks like a probability to you or not. Yeah, it does, right? It actually is a probability of rolling a number greater than 3 from one die. Okay, so we can say that this is the probability of rolling greater than 3 from die 1, and this is from die 2, and this is from die 3. How? Let's see. Say E prime is an event of rolling greater than 3 with die 1. Similarly, E double prime and E triple prime are defined for die 2 and die 3 respectively. Now consider E prime. The cardinality of E prime is 3 because the number of outcomes that are greater than 3 while rolling a die can be 3. How? 4, 5, and 6. These 3 numbers, that is why the number of outcomes in my expected event is 3. Similarly, the total number of results of the sample space of rolling a die, let's say the sample space is omega 1, and then the cardinality would be 6. There are 1, 2, 3, 4, 5, and 6, so the probability will be 3 by 6. Okay, see here. Similarly, we will find that P of E double prime is 3 by 6, and so will be P of E triple prime. Now we are going to put these values here and wait till our expected formula is derived. The formula we are going to derive is called the formula of independence. So anyway, my next question to you is there any relation among E3 and these newly defined events? Yeah, there is. So we can say that if the first die shows number greater than 3, and the second die also show number greater than 3, and the third die also show number greater than 3, then this event will represent E3. All right, because E3 is getting number greater than 3 from each of the dice. So if all these 3 events happen together, which means they're in a relation of intersection, then we can say that E3 happened. Now we are going to replace this E3 here by the intersection. Okay, also we are going to replace the right hand side fraction by these probabilities, so it will be like, see, we are almost there, we are in our desired formula. So this is not the rigorous proof of the formula. If you're interested in the rigorous proof, then we are going to provide it in your concise note. Now my question is, what does this formula state? It states that if 3 events are independent and are happening together, then the probability of all 3 of the events to happen together is equal to the product of the individual probabilities. Okay, this is not only true for 3 events, it can be 4, 5, 6, or numerous events that are independent events. So you must be wondering what independent events are. Okay, so if the incidence of one event is no way affected by the outcomes of other event, then we can say that the first event is independent of the other event. Okay, so the result of one event is not influenced or affected by the results of any other event, and then we can call that they're independent events. So what might be the example? Simply what you have eaten in your lunch is nowhere related to what marks did you get in your quiz 2. Okay, so your marks in quiz 2 and your lunch are 2 independent events. Similarly, we can say that you are rolling 2 dice and you are expecting 2 6 from 2 dice. Then the result of the first die is not affected by the result of the second die. Both of the dice can show any numbers independently. So these rolling of two dice are independent events. Similarly, if you're flipping 5 coins and expecting hit from all 5 of them, and then we can say that all of the events are pairwise independent. Pairwise independent means like coin 1 can show anything irrespective of the result of coin 4. Okay, so I hope you understand what independent events are. So now if A1, A2, A3 up to AN are n number of events which are pairwise independent, then the probability of all of these n events to happen together, which is P of A1 intersection A2 intersection A3 up to AN, will be equal to the product of the individual probabilities, like P of A1 times P of A2 times P of A3 and up to P of AN. Okay, so this is a very useful formula, and we are going to use this formula on and off in our future problems, so you must remember it. Now, in independent events, the incidence of one event doesn't affect the probability of the other event. Okay, so if A and B are two independent events, then the probability of both of them to take place together is equal to the product of the probability of A and probability of B. Okay, so here it is, P of A intersection B, sorry, P of A intersection B equals to P of A times P of B. So let's see an example and have a clearer idea what independence is and how the formula works. Okay, so the example states that suppose A and B are two parties competing against each other in an election. The election has multiple rounds. The probability of A winning a single round is 3 by 5. Okay, so clearly A has a higher chance of winning a round than B. And also, given that there is no tie, so either A wins or B wins a single round, there's no draw. Question 1 is, if there are 2 rounds, what is the probability that B wins both of them? So this is a question. Now, to solve this problem, the first thing we have to do is to define the events properly. Okay, so let's say event B1. Yeah, B1 is the event of B winning the first round. Okay, there are 2 rounds, so B wins the first round, and that is called the event B1. Similarly, we are defining B2, that will denote the event of B winning the second round. So for B to win both of the round, we want these to happen, right? Because when B1 and B2 both happen together, we can say that, yeah, B won both of the rounds. So we are interested in finding the probability of B1 intersection B2. Okay, now if B wins the first round, does it anyway affect the result of the second round? No, we can either win or lose the second round irrespective of the result of the first round. Therefore, we can say that both B1 and B2 are two independent events. Therefore, we are going to use the formula of independence here, where P of B intersection B1 intersection B2 will be P of B1 times P of B2. So P of B1 intersection B2 equals to P of B1 times P of B2. So these two values are to be determined to find the final value of P of B1 intersection B2. So let's start with P of B1, which means the probability of B winning the first round. Okay, so from a corollary that we derived after axiom 3 in our previous lecture, we can say that probability of B winning the first round plus probability of B not winning, i.e. losing the first round, equals to 1. Okay, probability of some event happening plus probability of that event not happening equals to 1. This was stated in a corollary in your previous lecture. If you don't remember it, just go back to that lecture and watch this segment carefully. So yeah, now we can say that P of B1 will be equal to 1 minus P of B1C. Now this B1C means B didn't win the first round, which is equivalent to A won the first round. Okay, so P of B1C equals to P of A1, where A1 is the event of A winning first round. All right, so why did we relate P of B1 to P of A1? Because the value of P of B, or B winning a single round, was not given in the question. The probability was not given, and the probability for A winning a single round was given, and it was 3 by 5. So we wanted to derive this value using P of A. Now 1 minus P of A1, which will be equals to 3 by 5. All right, 1 minus 3 by 5, because P of A1 equals to P of A2 equals to 3 by 5. For every single round, the probability of winning for A is same, and that is 3 by 5. So we have put this value here to find out P of B1. So it's 2 by 5. Similarly, we'll find that P of B2 is also equals to 2 by 5. So we have finally found our desired values. So now we are going to put the values here, 2 by 5, 2 by 5 multiplied. So the result is 4 by 25. So the probability for B winning both rounds equals to 4 by 25. Question 2 to all of you is, if there are 4 rounds in an election, find the probability of A winning the first 2 rounds and losing the last 2. All right, so this is the question. If there are 4 rounds of election, then find the probability that A won the first 2 rounds and lost the last 2 rounds. To solve it, again, we are going to define the events properly. So A1 means A wins first round. So A2 for the second round. A3 would mean A win the third round, and A3C will mean that A loses third round, and A4C will do the same for round 4. Okay, so we want all these 4 events to happen together. So intersection A2, intersection A3C, intersection A4C. The probability of it is what we are looking for. Now, the result of the first round is no way dependent on the result of the second. So all of these events are pairwise independent, just like the previous example. So we can replace the probability by the right hand side of our formula, P of A2 times P of A3C times P of A4C. All right, now we already know that P of A1, P of A2 are 3 by 5, 3 by 5, and P of A3C will be 1 minus 3 by 5, right? Because P of A3, P of A2, P of A1, and P of A4, all 4 of these probabilities are 3 by 5. That's given in the question. So the complement of this event will be 1 minus 3 by 5. Similarly, this will also be 1 minus 3 by 5. Now, multiplying all of them, we are going to get the result. I hope you understand it. So this is 3 by 5 square into 2 by 5 square. So it's 625 in the denominator and 936. Yeah, so the result is 36 by 625. All right. Okay, so another question that I want to give you to solve by yourself, and that is the question here. Read it. The question 3 states that if 10 rounds take place, find the probability that A loses round 2, 3, and 4 and wins the remaining round. So A has to lose the second, third, and fourth round and win the remaining rounds. So we need to find the probability for all 10 rounds together. Yeah. So our question 5 states that if there are n rounds in an election, find the probability that B won at least one of the rounds. Okay, so n rounds are taking place and we want B to win at least one of the rounds. So B can win one round, that's okay. B can win two rounds, that's also okay. So 3, 4, 5, 6, even all of the rounds being won by B is also okay. So what is unexpected here is we don't want B to lose all of the rounds. Okay, so this is denoted here by the red region. If you see this Venn diagram here, this is the sample space of all possible winning configuration for B. All right, so since there are n rounds taking place, so the minimum number of winning by B is 0. Okay, the minimum number of round won by B is 0, and the maximum number of round B can win is n. Okay, so all possible configurations are fit in here. Therefore, this is the sample space. Now, we are interested to find out the probability of the event represented by the green region. All right, where B is at least 1. Yeah, 1B represents that B won one round, 2B represents that B won two, and so on. Okay, so here are also some other events. So we can write that P green is something we are looking for. So P green equals to what? And we also know that probability of green plus probability of red, these two probabilities cover the probability of the whole sample space equals to P of omega, which is by our axiom 1. Therefore, P of green would be 1 minus P of red, right? So the P of red event can be replaced by P of 0B, which means probability of B losing all the events, or probability of B winning 0 rounds. All right. In other words, we can write it like P of A wins all n rounds. Okay. B winning 0 means A winning all the rounds since there is no tie. Now 1 minus P of this A wins all rounds, all n rounds, can be replaced by this. I hope you know the meanings of A sub I, A sub 1, A sub 2, A sub 3. Okay, A1 means A wins the first round, A2 means A wins the second round. So if all these events happen together, will mean that A wins all of the n rounds. Now the probability for A to win a single round is given 3 by 5 in the main question. So since all the single rounds are identical for A to win, so P of AN, all of these probabilities will be equal and they will be equal to 3 by 5. Now since these events are independent, because the result of any of the round is independent of the others, we can replace it by P of A1 times P of A2, P of A3 up to P of AN. Alright, now since all these values are equal and 3 by 5, so can you tell me, sorry, I need to raise it, can you tell me how many 3 by 5s are going to be multiplied here? 1 minus 3 by 5, 3 by 5, since there are n events, so n 3 by 5s are going to be multiplied, so 3 by 5 to the power n. Okay, so this is P green. In other words, this is the probability of B winning at least one round. That's it.